Now let's look at some additional limits from a graph. Let's compute the limit as x approaches 0 of f of x. We want to compute the limit as x approaches 0, so let's identify x equals 0 on the graph. Now we need to look at the behavior from the left of 0. That's this part here, and the function values are approaching -1. Now let's look at the behavior to the right of 0. That's this behavior here. And as x approaches 0 from the right, the function values approach 1. So notice that we have one type of behavior coming in from the left and a different type of behavior coming in from the right. In order for the limit to exist, the behavior on the left must match the behavior on the right. So because this behavior does not match, we say that this limit does not exist. Now let's take a look at another graph. First, let's look at the limit as x approaches -4 of f of x. Let's locate -4 on the graph. Now let's look at the behavior to the left of -4. That's this behavior here, and notice that the function values are approaching 2. Now let's look at the behavior to the right of -4. As we approach -4 from the right, the function values are approaching 3. So we are approaching 2 from the left, 3 from the right, and these values don't match. So the limit does not exist. Remember that the actual function value has nothing to do with the limit. So at -4, the function value is 2, but the limit did not exist because the left behavior did not match the right behavior. Now let's compute the limit as x approaches 1 of f of x. 1 is here, and notice that we have the function defined at 1 here. But remember, we want the limit, not the function value, so we need to look at the behavior around 1. So as we approach 1 from the left, the function values approach 3. And as we approach 1 from the right, the function values also approach 3. So we would say that the limit as x approaches 1 of f of x is 3. Here, the function value at 1 was 1, but the limit was 3. So remember, what's happening at the point is not the same as what's happening around the point. Now let's compute the limit as x approaches 3 of f of x. 3 is here, and now let's look at the behavior coming in from the left. As we approach 3 from the left, the values just keep going down and decreasing. And as we approach 3 from the right, the values just keep going down and keep decreasing. So remember, whenever we compute the limit, we need to be approaching an actual value. Even though the behavior is kind of the same, like they're both decreasing, that's not what the limit is here. The limit is an actual value that we are approaching. So these just keep decreasing forever and they're never going to reach a number, so we say that the limit does not exist. Now let's find the limit as x approaches 4 of f of x. 4 is here. This is the behavior from the left, and the function values are approaching 1 to the left of 4. This is the behavior from the right, and the function values are approaching 1 to the right of 4. So we say that the limit as x approaches 4 of f of x is 1. Now if you look at 4, the function is not defined at 4 anywhere, and that doesn't matter. We don't care if the function is defined at 4 or not, we just care about the behavior around 4. Now let's find the limit as x approaches 6 of f of x. From the left of 6, we're approaching 2. From the right of 6, we're approaching 2. So the limit as x approaches 6 of f of x is 2. In this instance, the limit value is equal to the function value. The function value is 2 at 6, which is also the limit as x approaches 6, but these don't necessarily have to be the same.